Okay, the next problem we want to do is problem 15, which asks us to sketch the graph of this function here, and then hence sketch the graph of this guy here. Before we do that, we need to know a little bit about this function before we can draw a graph of it. Well, we don't need to know, but we will find out. So let's take that function, and one of the things we would like to know is where it's 0. So this is kind of easy to see. We can see that that graph, it has x plus 1 times x minus 8. I think it's true. Let's work that out. If I expand this out, then I'll get x times x, that's x squared, and the term in x will be plus 1x minus an 8x, and that's negative 7x, or minus 7x, and then the constant term will be plus 1 times negative 8, which will be negative 8. So, in other words, this function is 0 when x equals negative 1 and x equals 8. We can see that as x becomes very large, either negative or positive, then this term will eventually win over the rest of it, and so we can expect the function or the curve to tend to plus infinity. This is in fact a parabola. So let's get that. So we'll get the plot that we generated here. And copy that down here. The only difference being that we don't want to plot 1 over x squared plus 4. We want to plot this function here. And we know that we want to plot it for values including the places where it's 0. So let's take the plot from negative 2 to plus 9. We'll get rid of that because we don't need it anymore, and that's what it looks like. And we can see that indeed that the curve is 0 here and here, and it has a value, it comes down here, it has a minimum value of about 20. How do we solve the rest of the problem? In other words, we want to plot the graph of this guy. Well, what do we expect it looks like? For x less than negative 1 or greater than plus 8, then this function will be the same as the original one, but for values in the middle, it will just be the mirror image of this curve here. So let's do that. So we'll and then we'll plot comma abs of so this function, and then so that should come out in blue, and let's draw that graph, and you can see that that's exactly what it looks like. In other words, it's all this part comes out in blue now because we've put that on top of the first one. So so the blue curve is the graph of the square root of, sorry, the absolute value of that function. And we can understand why that happens. Okay, well, the last problem to be solved is this one: use a graphical approach to solve this equation here. So since that's what they want us to do, so we can plot both those functions using the tool that we developed. Well, we better get the text as well. So the two functions, the left-hand side and the right-hand side, can be plotted using, so that we'll put the left-hand side first. So let's plot that, see what we get. Well, what can we get out, discern from that? Well, those this equality will be satisfied by the points where these two curves cross. So we can see that they cross once here at near x equals 1, and they cross again out here for some larger value. So let's change we know that will happen because you see the slope of this this curve here is greater than the slope of this one, so eventually this will catch it. So let's do that, and still not far enough. So let's do 10. There we go. So we can see that they cut here and here, and that value looks like it could be about 7. So there are, to solve that, there are two cases to consider. We can see that one of the places is to the left of the cusp here, which is 5 over 2. So we can write for x less than 5 over 2, we have, well, for x less than 5 over 2, this will be just 5 minus 2x, because for x less than 5 over 2, the numerical value of 2x minus 5 is actually equal to 5 minus 2x. So we move things around, and we'll see that if we move the 2x over to this side, we'll get 3x, and if we move the 2 over to that side, we'll get 5 minus 2 is 3, so 3x equals 3, so x equals 1. And we see that the other root occurs here over near x equals 7, so we suspect that, well, that's certainly greater than 5 over 2. So we'll copy all that down here. And so for x greater than 5 over 2, we'll have 2x minus 5 is equal to x minus 2. And so if we move the 5 here over here, then add it to 2, then it becomes plus 5, add it to 2, that becomes 7. And if we move the x across to here, then it'll be 2x minus 1x, which is x, and so we'll have x equals 7.